Hi, let's talk about chemical formula or molecular formula. What is a chemical formula? A chemical formula is simply a representation of a compound. Just as we talked about chemical symbols, where we said a chemical symbol is a shorthand representation of an atom of an element. In this case, a chemical formula is made up of different symbols joined together with the number of atoms present in the compound. A chemical formula can be used in writing a simple equation where the number of moles of reactant and the number of moles of products are indicated. How do we write the correct chemical formula of a compound? To write the correct formula of a compound, there are certain rules that must be obeyed, and there are also certain areas that must be considered. Number one of these areas is the area of valency. For you to write the correct formula of a compound, you must know the valency of the individual elements that makes up the compound. Another thing you must know is the types of atoms that combines to form the compound. Based on that, we were told that a valency is the combining power of an element. That is, when an element undergoes a chemical reaction in combination of other elements to form a compound, there is a capacity or a power in which the element joins with other elements to form the compound. So, in knowing the valency of the element which makes up a particular compound, we can simply write the correct formula of a compound. Let's look at a simple element like oxygen that exists as a diatomic molecule. In this case, oxygen as a molecule, the formula or the molecular formula of oxygen can be written using the two atoms of oxygen joined together and with the symbol of oxygen written in this form as O2. So this is the molecular formula of oxygen. Take note, there is a difference between an atom of oxygen and a molecule of oxygen. Of course, an atom of oxygen is made up of just one oxygen, while a molecule of oxygen is made up of two atoms of oxygen. That is why we refer to oxygen as a diatomic molecule. Other elements that can exist as diatomic molecules are, we also have hydrogen existing as diatomic molecule. So we can say the molecular formula of hydrogen is H2. We also have nitrogen existing as diatomic molecule. So the molecular formula of nitrogen is N2, while the symbol of nitrogen is simply N. The symbol of hydrogen is simply H. So there is a difference between symbol and a molecular formula. Having said that, we said when a compound is formed, it has to do with two or more elements combining together chemically. So when they combine, there must be exchange of ions, and there must also be exchange of valencies to form the compound. Based on that, we can go to the next rule that states that for you to write the correct formula of a compound, you must know the valencies of the elements that make up the compound. While the next rule has to do with trying to interchange the valencies of the elements. The next rule is, having known the valencies and interchanging the valencies, it is important that you write the symbol of the metal first, that is the positive ion first, followed by the non-metal, which is the negative ion. In doing so, there are some elements that have variable oxidation state. So based on that, in writing the formula of those elements combined with another element, the oxidation state of the element must be indicated. So let us take a look at some formula of compounds, or the formula of some common compounds. Now, having said that, we can have, for example, a compound like sodium chloride. If you are asked as a student to write the correct formula of sodium chloride, what are those questions that will come to your mind? Number one is, what are the elements or what are the atoms that makes up the compound sodium chloride? Sodium chloride is made up of sodium and chlorine. So having known the elements or the atoms that makes up the compound, the next thing you will get to know is the valencies of the different elements. So here, the valency of sodium is simply 1, while the valency of chlorine is also 1. Having known the valency, we move to the next step that has to do with what? Interchanging the valencies. So here we can have exchange of valencies. So the positive atom takes the valency of the negative atom, while the negative atom takes the valency of the positive atom, just as it is shown here. So after doing that, it is stated also that we should write the symbol of the metal first, followed by the valency that has been interchanged, before we write the symbol of the non-metal, followed by the valency that was interchanged. So based on that, we can have the metal here, which is sodium, and the valency here that is interchanged, and chlorine plus the valency that is interchanged. So in this case, the 1 here is no longer needed. So we can have something like NaCl as a formula of sodium chloride. It is as simple as that. It simply shows here that sodium chloride cannot be written in any other form apart from NaCl. In any other form that sodium chloride is written is not acceptable in chemistry. Let us have another compound like potassium hydroxide. So we have potassium hydroxide. Okay, so we have potassium hydroxide. So potassium hydroxide here, from our set of rules, it was indicated that the first thing we put into consideration in writing the correct formula of a compound is to identify the atoms or the ions that make up the compound. So potassium hydroxide is made up of 2 basic ions, potassium ion and hydroxide ion. So here we have potassium ion written with K here and hydroxide ion OH. The next thing we put into consideration is the valencies of these 2 ions. So here we have the valency of potassium as 1 and the valency of hydroxide as 1. While the next step here is to interchange the valencies. Now having interchanged the valencies, we will now have something like K1OH. So because the hydroxide has 2 atoms, so we simply introduce a bracket to separate the different atoms. So we have K bracket open, OH bracket close 1. So because these 1 are not needed here, we can have the correct formula of potassium hydroxide written as KOH. So that is the correct formula of potassium hydroxide. Now let's go further to talk about other compounds like calcium trioxocarbonate 4. Okay, calcium trioxocarbonate 4. How do you write the correct formula of calcium trioxocarbonate 4? Of course, calcium trioxocarbonate 4 has 2 major ions. They are calcium ion and trioxocarbonate 4. Calcium ion has a valency of 2 and trioxocarbonate 4 has a valency of 2. Now having said that, let's look at how we can interchange their valencies. Looking at the illustration here. So by interchanging the valencies, we have the calcium here having Ca2, while the trioxocarbonate 4 having CO3. Now because the trioxocarbonate 4 is made up of 2 atoms, we simply introduce a bracket. So here we can see how the different valencies are interchanged. Now based on this, if we take a look at it, we can see a common number there which is divisible by the other, and that number is 2. So we can simply divide 2 here by 2, and what we have here is Ca CO3 as the correct formula of calcium trioxocarbonate 4. Still on chemical formula, let us take a look at another compound called potassium tetraoxosulfate 6. Okay, potassium tetraoxosulfate 6. Now, potassium tetraoxosulfate 6 is made up of two ions also. We have the potassium ion and the tetraoxosulfate 6 ion. So here, the potassium ion is having a valency of 1, while the tetraoxosulfate 6 is having a valency of 2. So by interchanging their valencies, we will have something like this. Okay, so we have the potassium K2 and SO4 bracket 1. So rewriting this, we have K2SO4 as the correct formula of potassium tetraoxosulfate 6. It is very simple, isn't it? Now let's take a look at other compound. This time around, we are going to be looking at potassium. We'll be looking at potassium let's look at potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7. Of course, potassium here has a symbol of K, while tetraoxomanganate 7 is written as MnO4 minus. Okay, so here the valency of potassium is simply 1, while tetraoxomanganate 7 has valency of 1 also. So interchanging their valencies, we can have something like this. So we have K1 in brackets MnO4 1. So here we simply have KMnO4 as potassium tetraoxomanganate 7. So that is how you write the formula of common compounds. Now, how about if we are given simple compounds that consist of two elements? Of course, the one with the examples we just did has to do with compounds that have more than two elements. Such compounds are called polyatomic compounds. What is the meaning of polyatomic compound? Polyatomic compounds are compounds that consist of 3 elements and above, and one of the elements are usually oxygen. So let's talk about simple compounds that consist of 2 elements. In this case, we are looking at binary compounds. So when we say binary compound, we are talking about compounds that are made up of 2 elements. Binary meaning 2. Okay, so let's take a look at the chemical formula of some compounds that are made up of 2 elements. Let's take a look at example of compound like zinc sulfide. Zinc sulfide. Of course, zinc sulfide is made up of zinc and sulfur. So the symbol of zinc is simply Zn, while the symbol of sulfur is S. So the valency of zinc is 2, while the valency of sulfur is also 2. So in interchanging their valencies, the correct formula of this compound is written as Zn2S2. So where these two will cancel these two, and what we'll have is ZnS. So that is the formula of zinc sulfide. It is as simple as that. We can also have a formula of sodium oxide. So we have sodium oxide. So when we say oxide, we are talking about element oxygen. So sodium oxide is made up of sodium and oxygen. So here the valency of sodium is simply 1, while that of oxygen is 2. So by interchanging their valencies, we have Na2 and O1. So the correct formula of sodium oxide is Na2O. So that is the correct formula of sodium oxide. Other compounds that we can refer to as binary compounds that are made up of only 2 elements are compounds like hydrogen sulfide. So we have hydrogen sulfide. Hydrogen sulfide. So hydrogen sulfide is made up of hydrogen and sulfur, with hydrogen having valency of 1, sulfur valency of 2. So by interchanging their valencies, I can now have H2S1, which is the same thing as H2S. So that is the correct formula of hydrogen sulfide. Let's take a look at the last example of binary compound, and we are going to look at aluminium oxide. So we have aluminium oxide. Aluminium oxide is made up of aluminium and oxygen. So we have aluminium here and oxygen. So here aluminium has valency of 3, while oxygen has valency of 2. So by interchanging their valencies, we can have aluminium 2O3. So that is the correct formula of aluminium oxide. With this, we've talked about so many examples on how to write the correct formula of compounds. Having talked about these examples, we can conclude by saying the formula of a compound gives us a clear insight on how the compound can be represented in a chemical equation in form of a chemical reaction. With that, we've come to the end of this class.